Hi madam, my name is Siti Andal binti Nur Azami. My ID student is 2022267690.
My name is Natasha Zairin binti Mazli Rizal and my student ID is 2022837462.
And my name is Lia Khalida binti Ahmad Kamal Hasrin. My student ID is 2022497734. Hi, I'm Lia. I'm gonna introduce this topic. First is related rates. The idea is to compute the rate of change of one quantity in terms of the rate change of one quantity in terms of the rate of change of another quantity. For example, if the value of the variable x is dependent on the time t, then dx over dt is called its time rate of change with respect to time. To find an equation that relates the two quantities, we can use the chain or implicit rule.
Question 1 is show a right conical container with a height h 10 cm. Water is poured into the container such that the height x centimeter of the water level increasing at a constant rate of 0.5 centimeter second per time. A shows the volume V centimeter cube of the space that is not filled with water is given by V equal to 16 over 3 pi 14 minus x cubed over 25.
For question B, calculate the rate of change in the volume of the space that is not filled with water when x equals to 5.
For A, we have to find the space of a cone that is not filled with water. So let's divide the cone into two. First is the big cone and second one is a smaller cone that is filled with water. To find the empty space, we have to minus these two cones to get the empty space. So as we know, the volume of a cone is 1 over 3 pi r square h. As we know, the smaller cone's radius and height is not given. So let's assume the smaller cone radius is r and the height is h. For the big cone, it's given the radius of a cone is 8 and the height is 10. Let's find the r for the smaller cone. So r equals to 8 over 10 h. Simplify it. It becomes 4 over 5 h. Find the volume of the empty space. Let's substitute all of the information in the formula. First, for the big cone, we have 1 over 3 pi. Our r is 8 square and our h is 10. This is for the big cone. Minus the smaller cone is 1 over 3 pi. The r is this one, 4 over 5 h. Square and h, since we don't know the height. Simplify this. For the big cone, we got 640 over 3 pi minus, for the smaller cone, we have 16 pi over 75 h cube. And then you can simplify it. 16, we get 16 over 3 pi. And we have 40 minus h cubed over 25. This is our answer for A. So after we got the volume of the empty space, the question asks us to calculate the rate of change in the volume of the space that is not filled with water when h equals to 5. So for dv over dh, we just have to differentiate v to make it as dv over dh. So let's differentiate dv. So dv over dh equals to 16 over 3 pi, differentiate 40, we got 0, differentiate h cubed, we got 3h squared over 25. So this is our dv over dh. Oh, I forgot the negative, sorry. Let's simplify this equation. So after we simplify it, we get negative 16 over 25 pi h squared. So when we talk about change of rates, first thing that has to come in our mind is the rate of change of velocity with respect to time, as it said by Dia just now. So dv, to find dv over dt, we have to use the chain rule, which is dv over dh multiply by dh over dt. So since we have dv over dh, we just need to find dh over dt, which is already given in the question, which is 0.5 centimeter per second. Let's substitute it into the equation. So first we have dv over dh, negative 16 over 25 pi. Remember, h is 5, so we have to substitute 5 into h. So we have 5 square multiply by dv over dt, which is 0.5 centimeter per second. So 0.5. Simplified, we got negative 8 pi centimeter cube per second. That's all for B.
Summary. The conclusion of the project carefully analyzes the mathematical solution or solutions to determine appropriateness to the real world setting in which the problem was posed.